The resistance R is given by R equals to V over I. If V and I are measured 2% greater and 1% less than the actual values respectively, use partial differentiation to determine the percentage error made in the value of R. The resistance, okay. So we've been given that R equals to V all over current, and they're saying that I is measured 2% greater and this is V and I is measured 1% less. So they want us to use the partial differentiation to determine the percentage error made in the value of R. So we have the general equation that we normally use. Change in R will be given by del R del V, small change in V, plus del R del I, small change in I, or in current. Therefore, we can get the partial derivative of R with respect to voltage. So we are being told that R equals to voltage over current, and we can express this one as voltage current raised to -1. We must know that if M is raised to -1, then this one is the same as 1 all over M. That's why here we have voltage over current, which is the same as voltage, then current raised to -1. We are saying so because this V of I is the same as V times 1 all over current. So when you apply this concept, then this is the same as current raised to -1. Therefore, we can get del R, we get the partial derivative of R with respect to V. So we have del R del V. So when we differentiate this one partially, of course, V will be 1, and then we remain with current raised to -1, which is the same as 1 all over current. So that is del R del V. You can also get del R del current or del resistance, the partial derivative of resistance with respect to current. So we have del R. So this is equals to, so when we differentiate this one with respect to current here, so we shall have, of course, we multiply with the power. Remember, when you are carrying out differentiation, we multiply with the power and then we subtract the power. Therefore, here we shall have minus 1 times V, then raised to 1 minus 1. So this equals to minus V over current squared. Now from V is measured to percent greater of V, so 2%, 2%, so this one will be del V will be equal to 0.02 of voltage, and then del I will be equal to minus 0.01 of current. So we can substitute in this formula. So we have del R will be equal to, now we have del R del V, which is this one, 1 all over current, and then del V, which is this one, times 0.02 V. Then of course we have plus del R del I, which is this one, it's minus V over current squared into, now it will be minus 0.01 current. Now minus and minus be positive, so here we have this equals to 0.02 V over current, so it will be plus, here we have V into V into 0.01 over, now this one factor will cancel with this, so that we remain with 0.02 V over current plus, now we remain with V, remain with 0.01 V over current is 0. Now V and V is there. This is common, we can factorize out, so this equals to 0.02 plus 0.01 V over current, which is the same as 0.03 V over current. So remember these ones, they are, so we shall take this one over the original value of R, which is V over current. So we shall say percentage change will be equal to this small value of R, which is 0.03 V current over the original value, which is V over current times 100. This will cancel with that. Then will remain 0.03 times 100, which equals to 3%. Thank you for watching and listening.